Hello guys, welcome you all for this end-to-end session of AI, ML and DL where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot. We are learning a lot each and every day. Hope the same thing for you guys. Guys, today we are moving on to the coding part of deep learning. Okay, so as always, make sure you guys watched all the previous session videos so that you can have a better understanding of what we're gonna talk. Okay, so today is the coding part of ANN, the first deep learning networks algorithm. Okay, guys, this is what the collab. I hope like everyone who has followed us. Um, so who has followed us till now, you guys already know. Okay, right? So because we this is a environment that we are using past, I think nearly like 1.5 months, right? So hope you guys have a better understanding of what this collab, how to use this collab, everything. If not, make sure you guys just go to the like a session far away. Like I think it's like nearly 60 to 70 session you go. Before that, learn this environment, what it is, how to use everything, and come to the session. Okay, let us understand the coding part of ANN, guys. Okay, it's got to be very simple. I will make it simple. Okay, let's move one by one. Okay, first thing, ANN. Okay, we're gonna import some necessary libraries like NumPy, Pandas. NumPy is used for numerical operation, whereas Pandas is used to treat the data in a form of a table, and Matplotlib is used for some kind of visualization activities, whereas this model selection, train test bit, where we're gonna split our data to training and testing part. Standard scale are used to make the data to a standard scale, like a linear scale. Then we are using something called as a metrics, which is accuracy score, in order to calculate the accuracy of our model, which we have tried. Then we are using TensorFlow. This is a new thing. From TensorFlow, I'm importing Keras, and from that model. Similarly, from TensorFlow, Keras, and then layer. Model I'm using sequential model. Layer I'm using dense. That's it. Okay, simple. Okay. Now let's move on and understand what the next thing is. I'm going to load the dataset. It's going to be a simple dataset, high-risk dataset. We have used multiple times during our machine learning process. We're going to see how it's going to do. Okay. From sklearn to a dataset, I'm importing load iris. I'm now loading it to a variable called as data. Data equal to data.data. The column is feature names, and I'm just giving this dataset. Target is data of target. That's it. I hope like this is confusing. Let's make it summarize so that we can understand what it is inside the data. Summarizing the data, we're going to see, we're going to describe the data, dataset.describe, because it is a value, it's a variable name, dataset.info and dataset.8. You can see this is a summary of a dataset where we are having each data, we are having 150 records. Okay, that is null values. Okay, and we are seeing the mean value, median, everything we are seeing. So by using this describe function, okay, then we are having info. Using this, we are seeing information that all the columns has all the records, that is 150 records. You see that supple length, supple width, petal length, petal width, which are like floating point, whereas the target value is an integer. That is okay. Okay, everything was integer so that the model can understand and digest. So it is using a memory size of nearly 6 KB. And printing the first 5 records, you can see supple length, it is a floating point. Petal length, sorry, supple width, it is a floating point. Petal length is a floating point. Petal width is a floating point. And then we are having a target value. Okay, guys, putting in a simple manner, it is like a flower species kind of classification data set, where we will be having Setosa, Virginica, and Vesicolor. Based on the supple length, supple width, petal width, we are going to classify what kind of species it is. Okay, let's move on. Okay, now, so we are just going for some kind of a null value thing, whether null values is present in this dataset or not. Dataset.isNull.sum, in order to treat whether the dataset is having any null values or not, you can see no, no null values. Okay, so now our dataset has no null values, and also it doesn't have any kind of values which is other than a numeric, that because like we are having only floating point integer. Now it is ready to digest by the model, so that's great, right? Let's just move on and segregate the dataset into input and output. Okay, from this, you guys tell me, from these 5 columns, what is a column which is going to be our output? What are the columns to be our input? Simple, right? This target column is going to be our output. Remaining things are our input. Just see. We are dropping this target column. For X is our input, right? We are dropping this target column. That's it. Everything else will be our X. We are using only the target column. That is our Y. That's it. You guys see here, for data, that is X, we are having supple length, supple width, petal length, petal width. That is what our X. That's it. That's our input. Why we are having only target value 0, 1, 2? Okay, because set of virginical and vesicle 3 category. So this is our y, this is our x, and this is our y. That's it. Now, till this point, we have imported necessary libraries. We have loaded our data set. We have summarized our data set. We have split our data into input and output. We have done the pre-processing also. Okay, we have checked whether any null values are present or not. Moving on, let us perform the feature scaling, because like you guys see here, 5.1, 4.1, 4.9 like that. Here you see in petal length 1.4, petal width also 0. So you can see the drastic change, right? Here the values are in 5 point, but here it is 0 point. So what consideration the model will do means, as a human itself, we will thought that this column is a more important column than this column, right? So the model also thinks in same manner because it has a higher value, right? 5.1 is very greater when compared to the 0.2, right? So model thought only this column is more important, so it will give more importance to only this column. So we gonna scale it up so that every column becomes in the same scale, like -1 to 1, -2 to 2, anything related to this data set. Okay. For that, I'm just using the standard scalar. I'm just passing it to the variable, that is input variable, standard scalar.fit transform. I'm gonna have this to scale dx. Okay. You guys now see here we are having the value ranging from -9 to 9, I think so. Okay, or -0.7, something, -1.121. So this is how the data looks, guys. Okay, -1 to 1 standard scale. Now you guys see here there is no difference, so model gonna use all the data, okay, in the same fashion, and it gonna treat everything as the same. Okay, let's move on. Okay, we have done with standard scaling. Now we're gonna split our data into input, like train and test. Using train test split, I'm gonna pass my scaled x and my input y. I'm gonna split the test size, that is 0.3, that is 30% of data is for my testing, remaining things for training 70%. I'm fixing the random set to 42 so that whoever runs this notebook gets the same output. Okay. So now we are having x train, x test, y train, y test. You guys see here, simple, right? We are having x train dot shape, y x test dot shape, y train dot shape, y test dot shape. Simple. Okay. You guys see here, for training we are having nearly 105 records. For testing we are having only 45 records, because like 70:30 ratio. That's it. Simple. Okay, guys. Till this we have completed a first of our work. Only thing remaining is we need to build our model, train it, and we need to test it. That's it. Okay. So let's move on to it. Before that, I'm just summarizing what we have done. Means we have imported necessary libraries, we have loaded our data set, we have gone through what is in the data, then we have pre-processed our data, then we have split our data to input and output, then we have applied the feature scaling, then we have done with train test split. Okay. Now let us build this ANN, this model building. I'm going for sequential model. That is what the first thing. I'm going to give it to the model. That is a variable name. Model.add dense layer. I'm going to add a dense layer. That is 8 count. My input shape is extend shape of 1. So it will be like 4, right? 4 features are there. So that is what my input shape. I'm just getting from this input itself. Okay. Shape of 1. Already, guys, just see here. We are having extend.shape. Okay, which is this value tuple. Okay, I hope, like, guys, if you guys doesn't know tuple, please make sure you guys watch the Python video of us. Okay, 105, that is number of records. 4 is the number of features, that is sepal and sepal with petal and petal with. So that is what our input, right? 4. So what I'm going to do means extend.shape of 1. This is 0, this is 1, right? So it's gonna give 4. That is what our input dimension. Then activation function is relu in order to add a non-linearity, because then only it can able to understand the complex patterns. Now next layer I'm going to import something called as a 6 layers only. Okay, it's our tech case, anything we can do. And activation function is relu. Okay, we doesn't need to maintain the shape again. Okay, first layer only we need to define the shape, that is dimension. Next layer we can just go for number of dense layers that we need, then we need to inject the activation function. That's it. Final layer we need 3. Why? We need 3 outputs, right? Setosa, Virginica, vesicular, 3 outputs. So that we are defining 3. If it is 2, you need to put 2. If you are going to classify the numbers from 0 to 9, you need to get 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 values, right? You need to put the last layer as 10. This is very important. This one and this one is very important. You need to specify the number of outputs in the last layer. 3, activation function is softmax, because we need to have a probability value. In order to get the probability value or more than 2 values, you need to go for softmax. If it is only 2 values, you go for a binary. Okay, I hope like I have explained this model building step perfectly. Okay, these two things is important. Dimension you need to give properly, and the final layer, the number of count should be same as the number of count that you are expecting for your output. Okay, this is the simple way of building the ANN, guys. I hope this is a simple way of how you can build a ANN. Okay, I hope I have properly explained you guys. Let's move on to the next thing. Model dot summarize, guys. Just see here summary of a model what we have built. Dense layer 1, 2, 3. So 8, 6, 3, same, right? Number of parameters 40, 54, 21. So guys, this model that we have built, right, it has nearly 115 parameters. That is what the total number of parameters or total number of layers or neurons that it need to learn for our data. Okay, so guys, I hope like you guys are understanding, right? Simple way, we are just building our own ANN. Okay, now we're gonna compile and train our model. I hope like you guys already know what is compilation. We just created some kind of a network. We're gonna compile so that the network will be created as a structure, skeleton. Then we're gonna train it. Model.compile. Optimizer is Adam. I hope like guys we have learned optimizer, right? Non-linearity. Then loss function is partial categorical cross entropy, because like we have learned, right, we need to go for a calculation of error calculation, so that for each iteration the error will be reduced, accuracy will be increased. So for that we are using the loss function of sparse categorical cross entropy. Then the matrix is accuracy. Each and every stage we're going to see loss should be reducing, accuracy should be increasing. Okay, that is what we are compiling it up. Now model.fit, guys, I give a 2 seconds of time. What is meant by fit? Just ping in the comment section. Okay, training. Okay, we're gonna train. Model.fit x train y train. This is what the training data. I'm going for 50 epochs. That is 50 times of learning. Sir is saying that we should learn double, triple like those. But like here, you guys see here, we're gonna go for a 50 learning with a batch size of 4. That is, we're gonna get 4 records for each time. Verbose 1, that means it's gonna show our output, show the output. Otherwise, it will not show. Validation split is 0.2. From the training split, I'm going to get the 20% of data. Once it is completed each and every step, right, we're going to throw this validation to the model, and we're going to check whether it is working properly or not. Now, just see here, just consider this. You need to consider the validation accuracy and loss. Guys, this is 1 to 15 epoch that we are having. Just see here, accuracy should be increasing. That is, validation accuracy should be increasing. From 23, guys, 0.2381 means you need to multiply by 100. So 23, 23, 28, 42, 42, 42, sorry, 52, 61, 76, 80, again 40, 40, 55. My God. Okay, 80, 80, like that. It keeps on increasing and touching 90. Oh my God, 95. We are reaching an accuracy of nearly 95. And the loss should be reducing, right? It starts with 100% loss, guys. 160%, 116% of loss. 100. So like that, this keeps on reducing 60s, 58 to something to nearly to 35%. That's it. Okay. That's the reason how this model works. It is keeps on increasing the accuracy and decreasing the loss. So for each and every epoch, it is training and it is getting the things done. Okay. Hope you guys are understand, right? Training is completed. Now let's go and plot the graph. Okay, the same graph, guys, that we're gonna see. History is a variable where we're gonna have all this information. From them, I'm gonna get this accuracy, loss, validation accuracy. Okay, that's it. Okay, you can consider this accuracy also. This accuracy and loss for the training data. This validation accuracy and validation loss is for the validation data. Okay, you can consider anything, but validation thing you need to consider, because like this is what testing for the model. Okay, this accuracy and loss is the training data, training accuracy and loss. This val accuracy and val loss is the data which is present or given by the validation after completion of each and every epoch. Okay, I'm gonna plot it out. Just see here, guys. We're gonna create a figure. Okay, a size of 12 cross 5. I'm gonna create a subset, 2 figures that should be 1 comma 2 comma 1. History of loss, training loss, val loss, the label. I'm going to give a title as loss curve, and x label it should be epoch, and y label is loss, and then I'm going to print the legend. Similarly, I'm going for something like 1 comma 2 comma 2. That is, first this one comes the first plot. This one comes as a second plot. That is, here we are just changing the loss to accuracy. This is training accuracy. Val accuracy is validation accuracy. I'm just giving the title as accuracy curve. My X label is accurate, like epoch, and the Y label is accuracy, and then plotting the legend. That's it. PLT.tight. So you're gonna tight these two figures together, and TLT.show. That's it, guys. I hope it is visible, right? This is what accuracy, like loss score, it should keep on decreasing. You guys see here, from first epoch, that is 0th epoch, to 50th epoch, the loss should be keeps on decreasing. Okay, that's the thing, guys. Okay, guys, are you guys able to see here? It starts from 100% to keeps on reducing to 35% for validation loss, whereas training loss, you see here, it reaches nearly 0.1, that is only 10% loss. Now accuracy, you guys see here, it starts from validation accuracy starts from 10 to it reaches nearly like 95, right? Whereas for this training, it starts from 31% to it reaches nearly like more than 96, like that. Okay, because we can see this. Okay, what is the training accuracy? 83. Okay, sorry, at the final layer we are having, that is layer number 50, that is 15th epoch, we are having nearly 98% of accuracy for training data, but for validation we are having 95. That is what the same thing that we are seeing here. Okay, 95 validation, 98 for training. That's it. Okay, this is how you can interpret this graph. Okay, guys, I hope like you guys are able to understand, right? Perfectly. Okay, now let's move on to the next thing. Now I'm going to predict by using the train model. np.augmax of model.predict x test, all the testing data, access equal to 1. That means it's going to consider only columns. Okay, I'm going to pass the test data to the model.predict. I'm going to get the augment max. That is what it's going to do, means we're going to have three values, right? It's going to throw the probability value of 3. For example, it says the Setosa is of nearly like 0.4%, that is 40% of Setosa, 30% of Vesinica, and 30% of vesicular, then 40% is high, right? That is what augmax is do. It will take the 0th value, because that is what the highest value, probability value. Instead of that 40%, we will be having 0.4, 0.3, and 0.3. 0.4 is high, right? You got to take that. Okay, I'm going to give it to the y prime. You guys see here, we are having a value of 0, 1, 2. Okay, everything. Setosa, Vesinica, and vesicular. Now, let's consider what is the validation accuracy. That is, sorry, accuracy. Okay, test accuracy. We're going to pass the test data. That is, y test is the value which is present in the data set itself. Y prime is a value which our model finds. We're going to pass to the accuracy score. I'm going to print this accuracy into 100 so that you can get the exact percentage. I'm going to restricting to the float point of 2. That's it. And you guys see here, we are having 97.78%. 97% of accuracy we are getting for the test data. Okay, perfect, right, guys? Everything works fine till this. Okay, let's move on and predict for a single output. Okay, I'm going to pass the test data, first test data, and reshaping it to -1, 1, 1, minus 1. I hope like you guys already know, right? Because we have trained the model in that manner. I'm going to pass, get this single sample. I'm going to pass this to the model.predict single sample. I'm just passing this X label, that is going to consider as a column. And augmax, you know, right? We're going to have 3 probability values, because like there's 3 output. Setosa, Virginica, and vesicular. Whatever the output is high, we're going to get the augmax. That value could be returned to this single prediction. So single prediction of 0, that is our model predicted output, that is 1. I think it's Virginica. Okay, actual class that is present in the dataset itself, it is Virginica. Okay, so that's it, guys, because like we have done with this X test which is already present in the model, value of 0. Okay, that is all about how we can build this ANN and go for the entire code base. Okay, hope you guys have understand, guys. Is there any doubts, guys? We have done with the coding part of ANN, guys. Okay, so I hope like it's a simplified thing. Okay, this is how the ANN works, entire end-to-end part. So I will just summarize again. We have imported the necessary libraries, we have loaded our data set, we have gone for summarizing our data set, we have done the pre-processing, we have gone for splitting the data to input and output, then we have gone for something like um, uh, input and output. Then what we have done, we have done for feature scaling, then training and test split, then we went for something like model building. We have built our own AN model, then we have trained it, compiled it, trained it, then we go for a prediction. We have seen the metrics of it, testing value, testing metrics. We have done from graphs also, right? loss and accuracy graph. Finally, we went for prediction of a single sample. Okay, hope you guys have enjoyed. Okay, I hope like everything is clear. If till now, if any doubts, guys, please don't hesitate. Just ping in the comment section. We'll take up and we'll solve your doubts. Okay. So hope you have enjoyed enjoy the session, guys. This is what the flow gonna be, guys. Again, we're gonna see another topic. Then there is a coding session for it. Everything it's gonna be following the same manner that we have followed for the machine learning process. Okay. Hope you guys have enjoyed the session. We have enjoyed it a lot and we have learned a lot. We will until next session. Bye, guys. Take care. And wait. One more thing. Okay, guys. Make sure please subscribe to our channel because like every day we are just giving a new video, right? We are just uploading a new video. So just subscribe and hit the notification icon. Whenever we apply upload a new video, you will get the notification. So you will not miss any of our videos. And one more thing, there is 2000 plus quizzes which is available in our YouTube channel. Please go and attend the quizzes, guys. Uh, I doesn't need an exact answer. Go and attend the quizzes. That's a major thing. That's a starting point of learning. Do that, okay? And make sure if you any doubt, just ping in the comment section. We are here to help you, okay? So that's all from my side, guys. I hope like this session is very interesting and very enjoyable. Hope everything goes good. Okay, very interesting. Okay, I'm very happy. Like we are just teaching in a manner of black box coding everything together. Okay, so yeah, guys, that's it from my side. Thank you, guys. I'm signing off. So we will all meet in the next session. Bye, guys. Take care. Bye, guys.